the Data Science Festival. I'm excited to bring to you our 10th festival. I'm Amoja Pawar, and thank you so much for coming here and creating such a thriving community. I would request you to please put your phones on silent. A schedule for today's talks and session is present in a booklet that's in your swag bags. If you have any questions, please reach out to a DSF team member. We will be wearing the staff t-shirts. And there's free water at the back of the room, so please feel free to help yourself. Data Science Festival is about celebrating all things data. We try to bring together community members of the tech community, and we try to share and foster an environment where we would share knowledge, insights, and ideas. I would like to request everyone to please move to a new room if the particular room is occupied. So just a reminder that all the talks and sessions would be recorded and will be available and uploaded on the Data Science Festival website, as well as the YouTube channel. So if you missed a session, you can go back and watch it later. And the event is free to attend, and it's built by the community. But without the help of our sponsors, we wouldn't be able to make it a success that it is today. So I would like to extend a huge thank you to our sponsors, Data Idol, BSI, The Trade Desk, OpenCredo, Snowflake, Dan Humpy, Depop, Meta, NVIDIA, Key Insurance, Innovate UK, Bridge AI, and our bar sponsor, Shredens. Special thanks to our creative communities who have organized the logistics for the day, our AV sponsor, Streambased, and finally CodeNode for providing such a wonderful venue today. Thank you again for attending the DSF Festival. Also, don't forget to check the back of your booklet for a free pint of beer. And don't forget to participate in the DSF competition that's also mentioned on your booklet. I would like to welcome our first speaker for the session. It's Siddhant Agarwal. He leads the developer communities for APAC at Neo4j. Previously, he has pioneered India's first fintech community at Open Financial Technologies. He's going to enlighten us with his talk title, GraphRAG, Powering Up LLMs with Knowledge Graphs. Let's welcome Siddharth to the stage, everyone.
All right, let me just set this up. Perfect. Can we switch the slides? Awesome. Hi, everyone. Good morning. Good morning. Can't hear you. Come on, you guys had some food, some coffee. Yes. Good morning. Good morning. All right. That looks better. Yes. We can do much better. Yes. Good morning. Good morning. All right. Great. Lovely. Good to see this live audience. I know it's Saturday morning. You guys are feeling that why this chap is over here standing and talking to you. Well, I'm going to enlighten you with GraphRAG. But just before that, a quick introduction about myself. I am Sid. I am not based in UK. I'm based in India, based in Bangalore. Delhi is my hometown. Living in Bangalore for last decade, roughly. Started off my career with IBM as a Java technology engineer, but soon turned my passion towards community building, developer relations, talking to developers into profession, and that's what I've been doing for last decade, DevRel, community building. Yeah, and at the moment, I'm leading developer relations for Asia Pacific at Neo4j. So, okay, who has heard of Neo4j or worked with Neo4j? Wow, I have an awesome audience. Lovely, that's good. Who has not heard of Neo4j or not worked with Neo4j? Okay, roughly 20% of you. That's fine. Who has not heard of LLMs here? Anyone who has not heard of LLMs? Anyone, by any chance? Okay, everyone has heard of LLMs. Worked with LLMs, yes. Using it for work or pleasure, yes. Okay, perfect. My job is easy over here. But for those of you who have already worked with Neo4j or know Neo4j, I'm just going to give a quick refresher for those who have not. So those who have worked, please just bear with me for next 2 or 3 minutes. I'm just going to give you a quick download of what are graphs, what is Neo4j, and then we'll jump on to the actual part, which is what is GraphRAG and where we are positioned in the entire GenAI ecosystem. Sounds good? Yes? Awesome. Great. So when you Google graphs, this is typically what you get like in the images section, like charts, pie charts, some line diagrams. But this is not I am interested in. What I'm interested in is this graph theory. And that's the foundation of the graph databases as well. And that's where the entire journey of Neo4j also started up. Anyone heard of Panama Papers? I'm guessing. Yes? Great. Now, this is a very interesting and classical example that I love to quote every time when I'm talking about graphs and people want to know what graphs are. And can you give me a real-world example? So these folks at ICIJ, International Consortium of Investigative Journalists, they were handed over 2.6 TB of a hard drive, which had 11.5 million documents, emails, scanned documents, bank statements, and a bunch of other things. Now, eventually, they wanted to make some sense out of this document. But how to start off with? So they came up with this kind of a structure. Of course, not exactly this, but something similar of that sort, where you say that there's a person who has an account, and that account is with the bank in US. The same person lives at a particular address, and at the same address, there's another person who lives, but this person B, is an officer of another company. Now, this company is registered with another bank, but this bank is now a bank in Bahamas. And there's this money that's being getting transferred from one entity to another entity. And this is ultimately a very smaller part of the bigger picture that I want to show. So eventually they started drawing these in a whiteboard, making some connections, making some sense out of it, and eventually used Neo4j later on, as I said, and they came up with this kind of a structure. Again, this is just a smaller piece of the bigger picture out there. So how it starts with nodes. So that's the foundations of graphs. That's the foundations of Neo4j. So nodes represents your things. These can be identified by one or more labels. Like over here, I've given an example of movie. So I'm saying Toy Story is a movie. I've given a label as movie. It's also an animated movie, right? And these nodes hold data in the form of properties as key value pairs. So I can say that this movie has the title Toy Story, and it's released in 1995. Now, when you have multiple nodes, what connects these two nodes is the relationship, or we call it as edges as well. So relationships have a type. So I say that I have two nodes over here. One is my actor node, another one is my movie node. The relationship between the two nodes could be acted in. So Tom Hanks acted in movie, and then I can also define some properties on top of relationships as key value pairs. Again, I can say that the role that Tom Hanks played in Toy Story was the role of a Woody character. And what's very critical over here is the direction. So directions are super important in Neo4j, how you are traversing the graph as well, and also to understand how one node is connected to the other node. Now that's theoretical, but how it works in action, we use something called a cipher. So cipher is, think of it, the way you started off your journey with relation databases, you used to use, or you're still using maybe, structured query language, SQL, right? Now, ISO, in the last 40 years, has not invested in any other language, any other standard out there for databases. And they recently launched something called as Graph Query Language, GQL, as a standard language for all the graph databases. And Cypher has been contributing a lot to has already contributed a lot to the development of Graph Query Language. So your learning curve is going to be super, super easy once the migration is complete for everyone, all the graph databases over there to GQL. So Cypher is our proprietary language for now. It's a declarative language, very easy to use. It's like a pattern matching language. So I can say that if I want to identify this kind of a pattern that a person acted in a movie, that find this kind of a pattern if something like this exists, and then based on that I can just query and then find whatever, or just retrieve whatever is relevant to me. So all my nodes are turned into round parentheses over here, like person is my one label, movie is another label, so it's added in the round parentheses with a colon, semicolon before that. And then my relationships are in my square parentheses with dashes representing, dashes and greater than or less than sign representing the direction. Very simple, very easy to understand. P, R, and M that you see are the optional variables that are used to query the graph database. Some examples, you can write to Neo4j, you can create a pattern as well. If it doesn't exist, you can create this pattern, like person acted in a movie, and put these property keys as well. That's one option. There's another way of creating, one is called as merge. So you create all the nodes first, then you create relationships, and then you set the properties out there. That's another option of writing to Neo4j. You can read from Neo4j, like match, as I said, like it's a pattern matching query. You read from Neo4j, say match this relation, like if this relationship is found, then check for where the title is Toy Story, and then return me all the actor names, the roles as well. Now, if you look closely, this is very similar to your SQL statements out there. So your match is basically your from or your joins, your where is where, and then your return is essentially your select statements. But it's much more intuitive, much more easy to understand, much more easy to write as well. Now, for those of you who are still wondering, like, why do you move to relational to graph? I'm just going to make a super compelling pitch for you with, again, the movies database out here. Let's say we have directors, movies, and genres as 3 separate tables. Just making it easy for you to understand. Now, essentially, a simple one-to-one relationship between movie director and its genres would look something like this, where you have your IDs, primary keys, foreign keys, everything set out there. Super easy, yes, but movies can also have multiple directors. So what are you going to do? You are essentially going to just change the schema, yes? So you probably add in another table, put in another keys, make more joins, blah, blah, blah. You're bringing an unnecessary complexity out there, right? Or you like duplicate your data as well. So why you want to do that? And then movies can also have multiple genres. And again, I'm talking about a very simple example. Imagine a real world scenario where you have to go with multiple joins and there's multiple hops. It gets super, super complicated at the end of the day. So I'm nowhere going to migrate to that part. Eventually, I can put my entire data in this kind of a graph structure where I have a movie, can have multiple directors, and can also have multiple genres as well. Super easy for me. Okay. Recap, or just a concise information on how the conceptual mapping of relational to graph looks like. So your rows in your relational maps to your nodes, your joins maps to your relationships, your table names maps to your labels, and your columns maps to your properties. It's a good way to understand if you want to migrate your data from a relational database to a graph database. That's how you can think and model your graph database as well. While I always recommend, start just from a whiteboard, draw some circles, draw some lines, make some connections, start with that. It's super flexible. You don't have to restrict yourself with whatever you start with. You can always update, change, make changes as and when you go. So it's that flexible for you. So you should always go with that approach if you are comfortable, but if you're not, then you can always go with this approach for your structured data. And of course, once you have it in, if you can easily move your relational to CSVs or JSONs, we have CSV importers and JSON importers as well, making your life super easy as well. Okay, in a nutshell, we are a native graph database, but not just that. We also have data science and analytics capabilities on top of the graph database. We call it as graph data science. And this, for the analytics or for visualization, we have something called as Bloom. I'm not going to go into depth of it. I'm just cutting some corners over here because I really want to cover the GenAI part, which is why you are over here. So there are multiple development tools and frameworks. We started off as an open source product. We still have the open source offering. We still have a lot of offerings for the developers. Most of our products start as an open source, like start as a labs, and then eventually it comes into the product portfolio. And our drivers are still maintained by a lot of open source contributors, or we either just work very closely with them. So yeah. The last thing that is very critical is it runs anywhere. For those who have worked with Neo4j maybe 5 years, 6 years ago, they might feel that it's just an on-prem version, but there's no cloud offering. But yes, we have cloud offerings and multiple of them. There's a free cloud offering. And when I say cloud offerings, you have 2 options. One is run it database as a service, and the second one is you run it with any of our cloud providers, so like Azure, GCP, or Google Cloud. So you have a free edition, you have a professional edition, then you have a business critical edition, and then you also have an enterprise edition in the cloud offering. So, okay. These are some graph use case, but again, not just limited to this. We feel and we believe that graphs are literally everywhere. Everywhere that you go and see, you can see some or the other use case of graphs. You might not realize like directly, but indirectly there is some use case of graph. But these are top 6 use cases that have grown so well in the entire graph database ecosystem that I would love to highlight them. Okay, moving on to the actual part of RAG with Neo4j. So we know that LLMs make things up, they hallucinate. Essentially what is happening is that they're working with only one half of the brain, which is the right brain. They are super good in imagination, holistic thinking, intuition, arts. They might be good with facts, yes, but with only the facts that they're trained on. Now, we want to provide this left brain with something so that the entire brain is functioning and giving us a better contextual, a coherent response as well. So there are ways to avoid hallucinations. Again, for those who have worked with LLMs, with GenAI, they know that there's prompt engineering. You can just give prompt engineering. You can do in-context learning. There's fine-tuning of models that you can always do. But what's interesting is how I can put my domain knowledge, the enterprise information, and build more accurate, contextual, and explainable GenAI applications. I can avoid hallucinations with a bunch of those things, but then how I can put my domain knowledge as well to further avoid the hallucinations. So then they came up with a concept, the researchers and developers came up with a concept called VectorRAG. How many of you are familiar with VectorRAG? Everyone, almost? Who's not familiar with VectorRAG? Okay, cool. So essentially, what is happening is, for those of you who are not, just a quick 30-second refresher on that. So when you talk to ChatGPT, and I'm talking about the time when ChatGPT launched, you just query ChatGPT. It's a user who is asking a question to an LLM. The LLM is giving back a result. But what's missing is that are the responses accurate or not? So we provide some additional sources. We append some additional sources in between so that your response is much more accurate. And that's what changed in RAGs when vector RAGs and RAGs came into picture. So you gave in a bunch of PDFs, and then you chunk them, convert them into vectors, and then store it in a vector database. Now, when a user asks a question, eventually they are retrieving the relevant documents, doing some semantic search on the documents, on the vectors that's stored in the vector database, passing it or feeding it to the LLM. LLM is re-ranking them or understanding them, and then giving you a kind of a concise answer or generate an answer which is much more human-friendly. So that was what's still happening, is happening, and maybe would happen. But there are use cases where this naive vector search fails miserably. Now imagine I have a database where there are so many contracts. Now, almost, like hypothetically speaking, let's say I have 100 contracts. In those 100 contracts, 80 of them or 60 of them have a mention of Acme Incorporation. But my actual contracts with Acme Incorporation would be, like, which are signed with Acme Incorporation, would be maybe just one or two of them, right? So if your contracts are getting chunked, put into text chunks, vector index, and retrieving, there are higher chances that in such kind of situations where I'm asking that what are our contracts with Acme Incorporation, it might also give you the contracts which are not specifically with Acme Incorporation, but have a lot of references of Acme Incorporation, and eventually the vector database will feel that, yes, oh yeah, these are the contracts of Acme Incorporation, which is factually incorrect. And yes, there are a bunch of other reasons that we feel that RAGs with vector databases alone fail short. So it leverages only a fraction of your data beyond your simple metadata. Vector databases alone fail to capture relationships from your structured data. So relationships also exist in your structured data. I'm going to cover in a while. It misses out on the critical context. So it struggles to capture your connections across your nuanced facts, your multi-hop, domain-specific questions. I'm asking something, and then I'm not giving the entire history of what I asked earlier, but I say, okay, and then this, and then this, and then this. It has to go in a multi-hop as a domain over there. A lot of times you feel that vector similarity is equivalent to relevance, but no. Vector similarity is not equivalent to relevance. You might get duplicative results as well. And the fourth is very critical to enterprises these days. Everyone's talking about avoiding hallucinations, but what about explainability? What about traceability? How I can go back and check where and how this chunk has been come, or where this response has come to me. So the black box nature of vectors lack transparency and explainability, and that's what GraphRAG helps you achieve. So let's look at GraphRAG in action. For someone who is started up with LLMs, or this is how the journey looks like. You have an API key, like 70 lines of code. A few weeks, you felt amazing. Oh man, I'm the best GenAI developer in the world. But eventually, that's not the case. Your expectations are super high, but then it starts failing in some point of time. And then you feel that, okay, can I do some model selection, some fine tuning, some parameter tweaking? I can do some RAGs things. I mean, that's okay. But again, there's some hallucinations out there. But where's the opportunity? The opportunity lies over here with knowledge graphs. And that's where, before I really jump into the GraphRAG, how the GenAI structure architecture looks like with GraphRAG, I want to cover up quickly on knowledge graphs, what knowledge graphs are about. So knowledge graphs, in a very simple laymanish term, think of multiple graphs which are independent, but then they also can connect with each other. So it's a combination of multiple subgraphs, like in a very, very laymanish term, simple terms. So imagine in this example over here, you have probably two or three graphs which are connected together and eventually forming a bigger knowledge graph. So one could be my graph on person's interest. So I have Lily and James as two persons over here, and then they have relationships with each other. They are friends. Lily's a person, James is a person, of course. And then Lily's interested in Da Vinci, and James likes Mona Lisa. Now, you see over here that how smartly then you can connect from one graph, which is the interest graph, like person's interest, to the actual information, which is Da Vinci and Mona Lisa. Da Vinci painted Mona Lisa. Mona Lisa, A. Washington is about Mona Lisa, blah, 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 and stuff. Now, and also there is a third graph, which is that James has visited a museum in Paris, and this Paris is located, there's an Eiffel Tower that's located in Paris. Paris is a place. So eventually you're connecting a bunch of subgraphs together and forming a bigger knowledge graph to make sense out of it. So it's like, imagine walking into a library where instead of books being isolated, they are connected by relationships like written by whom, about, and related to what. So essentially, your knowledge graph is turning your scattered data into a cohesive, connected system. So when we talk about knowledge graphs, we are talking about broadly two types of knowledge graphs. One is your lexical or document graph, where your chunks. So again, we are slowly moving towards the GraphRAG part. We are not getting away with the vector approach. We are appending the vector approach with the graph traversal. That's what we're going to see in a while. So your chunks are there, your vectors are there, still there. So your chunks are also represented. Your entire documents are also represented in a graph representation. Your chunks are also represented in a graph representation, and there is some relationship between them. I was reading somewhere yesterday or the day before. So when you're chunking, you of course have to put some railguards to say that you don't give the entire thing as an entire document. You break it in chunks, or how would you know that this chunk is also related to the other chunk? There could be one information which is coming in the first chunk and passing on, like just adding on to the next chunk as well. But that gets missed in the vector representation out there because there's no connection between the chunks as well. The second one is your domain or entity graph, which is your real world or digital world modeling of your graph, graph representation of your real or digital world modeling. So for example, I can say Andreas works at Neo4j, Andreas lives in London. A very simple structured information I know how I can form nodes and relationships out of each other. Now the beauty about these two graphs is that they don't work independently, they are mutually connected, they're not exclusive to each other. So you can also have, and that's where the GraphRAGs is, where you have one chunk which also mentions some of the entities or has some relationship between entities and relationships within my structured data as well. Okay. So knowledge graphs are a flexible representation of data. As I said, you have a combination of vector, unstructured and structured data. And then you do graph traversals. So your vector search is there, your graph traversal is there, and then this additional thing which is called as graph data science that you can just top it up and get more information based on certain customers. So day before yesterday, we were doing a workshop where we were talking about how I can find, or rather how I can recommend to a customer that there are products which are purchased by one customer but also purchased by other customers. So that's where the graph traversals plus GDS comes into picture with vector similarity, of course. So all in all, you're fixing your LLMs by adding the left brain, which is your knowledge graphs, which makes it more explainable explicit, and factually correct. Okay, I have a couple of demos that I'm going to show, but overall, this is how the GenAI architecture would look like when you're grounding your data with knowledge graphs in your 4J. It's again, as I said, it's not independent to any other technology, open source technology or developer frameworks out there. It's a rather entire stack that you can take up and build on your own. You can move things around for orchestration if you want to change from LangChain to Llama Index or to Haystack or to Spring AI. We have integrations everywhere. You want to use Python, you can use JavaScript, you can use any other languages out there. Streamlit, Gradio, Vercel, wherever you want to host them, you can host them. Any embedding models out there, you don't have to restrict yourself with only these that mention. Anything else that you want to, you can do that as well. Use it for text generations, chat, or embeddings, or whatever it is. Okay, so let's do this quick quiz just to make sure that we are on the same page. So how it works is think of it in the same sense. We have 3 elements, 3 characters. So one is your human who is interacting with the chatbot. Then there's VectorRAG, which will have clues and vectors. Then it will have GraphRAG, which will have clues and vectors, plus the relationships around the clues as well. So just think in that sense, but don't be weird that just what is this? So you'll get to know about it. Just for the reference I'm showing over here. So the question is, who in the Beatles played in another band together with Jeff Lynne? Any idea? Any Beatles fans over here? Yeah, but I'll you know the answer. But I mean, for those who are not, I mean, eventually the human response would be, I'll think about the main players or main members of the band, then probably John Lennon or Paul McCartney will come into mind. Now, if you say John Lennon, then probably that could be an answer, but he went on to play with Yoko Ono in Plastic Ono band, right? So we know that there's no member called Jeff Lynne in Plastic Ono. If in case you know, then okay, so that's out. John Lennon is out of the game. Then Paul McCartney, maybe. I mean, unless you are believing the conspiracy of him being dead and then there's a replacement, a lookalike replacement out there. So there could be an option of Paul McCartney, but then again, this is also incorrect. Now, if you append it with the clues or some additional information, which is, think of it as stored in a vectors format, and then you say that the chatbot says that, okay, fetches this information and gives you the names of these members. Again, by this information, probably I can say probably there's one option which is George Harrison or there's Ringo Starr. Now, Ringo Starr could look like someone who might ditch the team and then go and play with another band. But then eventually, if I have connections or if I have connections between these multiple clues of different bands, where I can say that there's a member who also has the same member in another band, there's another same member in another band, there's another same member in another band, so I can say and go back and read their individual vectors as well later on and come to a conclusion that the right answer would be George Harrison out here. You getting my point? So what I'm trying to convey over here is a combination of a vector and a graph traversal approach, if it kind of landed somewhere. This is for the first time I was trying this example out. I actually took reference from this nice blog written by Christopher. If you want to check out the source, feel free to read more about it. But essentially, that's what I was trying to build the connection, that you have the vectors, you have your actual information, but then what in the vector RAG, that's where the connections are missing. That's where GraphRAG is. And of course, the challenges we face in the real world are infinitely more intricate than the straightforward simplicity of this game. So let's go into the demo now. Now, before I go into the demo, I'm going to talk about what the dataset looks like. So it's about the financial statements of all the publicly listed companies in US. So they have to, this is a SEC EDGAR dataset where they have to file Form 13K and Form 10K. Form 13K is pretty simple, very straightforward information. You have asset managers, then you have all the companies. So there could be multiple asset managers managing multiple companies and vice versa. So I can just say that a manager owns company, I can form this relationship. I know that these are the number of stocks that's been held, that's the value of the stocks, value of the shares that's being held, and that's what's been reported on this particular calendar or this particular quarter. Now, what I'm appending is with the unstructured information, which is the 10K filings. Now, think of 10K filings as 300, 400 page, or rather bigger than that, of unstructured information about a single company. And I'm talking about maybe thousands of companies out there, where everyone has 300, 400 page document submitted. How I can convert those unstructured into embeddings and then probably have connections with my structured data as well. That's what we're going to see today. So you already have your manager owns company as a relationship. Now this company also has a document, and document will then have chunks. So eventually, if you're getting a chunk, then it can also go back and traverse the graph and say that this company is owned by a manager. So if I have to search anything around the manager specifically, I can easily and comfortably do that. Okay, let's look at it. So this is my chatbot, and what I'm going to ask is, and I'll show you both comparison between both vector only and vector plus graph approach. So I'm going to ask, name the asset managers exposed to investments in regulated companies. Now I'm asking very specifically about the asset managers over here who are exposed to investments in regulated companies. Do the companies really say that, hey, I'm a regulated company or I'm not a regulated company? No, right? So let's see if what the results are with the vector-only approach, and then it will also generate us for the vector plus graph. Hopefully the internet is good. Okay, so it says that based on the context provided, the asset managers exposed to investments in regulated companies are not explicitly named. Yes, that we know that. The context discusses regulations and requirements for bank holding companies, banks, asset managers, but doesn't provide specific names of asset managers with investments in regulated companies. So my vector RAG has failed over here. Versus a vector plus graph has said, here's a company of asset managers exposed in investments in regulated companies. So Tiger Management LLC is exposed to investments in several regulated companies across various industries. So what it did was it went to the unstructured data, found out what are the companies, what are they working on, and then eventually connecting it with the asset managers as well. And gave a very confident answer that these are the companies that are exposed to investments in regulated companies. Let's ask another context-rich question where we say, which companies are vulnerable to lithium shortage? I mean, how would someone know that I'm vulnerable to lithium shortage or not? Come on. Yeah, this is running on a free instance. Can't help. Okay, so based on the SEC filings, here are the companies that may be vulnerable to lithium shortage. I got some information over here compared to the last question. I got like, okay, there are some industries, aerospace, automotive, electronics. They rely on lithium-ion batteries for electric vehicles. Yes, we know that. Companies that produce lithium-ion batteries or components, they would, if the lithium shortage could limit the production capacity, of course we know this. This is, any dumb can also answer this. Lithium mining or processing operations, all right. Manufacture products with lithium-containing components. I mean, I'm not getting a definitive answer of that here. These are the companies that might be impacted with lithium shortage. Let's look at vector plus GraphRAG approach. What does it say? Okay. So here are the companies that appear most vulnerable to lithium shortage. I got a company name because this company is Magnesia Specialties business, and that's being filed in the Form 10K, that the company has a business around Magnesia Specialty, which produces magnesia-based chemical products that require magnesium-rich brine as a key raw material. And there is the lithium shortage could impact the supply of this as well. So there's a supplier relationship also that's generated out there. Delta Airlines. So we got aviation or aerospace in the earlier one, but there was no definitive answer of which company. I got over here in the GraphRAG approach where it says Delta Airlines Incorporation. They operate Monroe Energy, which is a refinery that produces transportation fuels. So lithium is a component in electric vehicle batteries, so a shortage could increase demand for traditional transportation fuels. And then there's another one, United Health Corporation as well. You see how the responses are much more accurate and context-rich when you're working with GraphRAG as an approach. But it doesn't limit over here. There's always a question that developers ask us that, can you make our life a little easier? You are always talking about complex things. GraphRAG or knowledge graphs look super complex to build at the first instance. Can you come up with something that can generate or create knowledge graphs from unstructured data without any writing any piece of code? Can you make it easier for us? Well, yes, the answer is yes. We have come up with something called as LLM Graph Builder tool. It's an open source tool, freely available. It's super easy to use, simple and fast onboarding from your text to graph. I'm going to show you in a while how it works. And all you have to do is just connect to Neo4j, upload your files, and generate graph. And it generates a nice graph. It picks in the entities. It picks in the relationships between the entities based on some background programming. We tell that, okay, these are the nouns, these are the verbs in my entire data. So pick in the nodes based on the nouns, pick in the verbs based on the pick in the relationship based on the verbs out there. Okay, let's look at a quick demo. So what I did was, so this is what my tool looks like. I can drag and drop PDFs, text documents, whatever it is. I can connect with web sources. I have an option to connect with Wikipedia or any other website as well. And then any of your cloud storage buckets as well, Google Cloud or Amazon S3. So what I did was I took this James Bond Wikipedia page, just was getting a little creative to see how the response is. And also I just use also this transport for London and give it to the tool to process it. And you also have the option to switch between the LLMs. So right now we are giving an option of 3 LLMs, but as I said, it's an open source version of it, which I'll talk to you in a while. So, but this again also will not require any of your keys. So it's free. So feel free to test it out. So you don't have to provide any keys for Gemini or OpenAI or Diffbot or anything. So just put your files and then click on generate graph, as simple as that, and it generates graph. If you want to control what entities or what information is coming, you can always go to this graph enhancement tool, and then you can get this schema from text. You can put some initial text and say that these are the entities that you should use. Don't go, these are the node labels or relationship types you have discovered, but don't use all of them. Use this only. So you can select, delete, whatever you want to easily from this tool as well. So let's test this out. What I'm going to ask is, I'm going to do some James Bond trivia over here. I'm going to say, who played as James Bond in the last movie adaptation and not TV adaptation. Okay, let's see. Please give me a good response. Was it correct? No Time to Die? Was this last movie? Yes, let's check back. The last movie was, yes, No Time to Die by Daniel Craig. And now if I want to ask and tell me the plot of this movie. Okay, getting a nice plot as well. No Time to Die, James Bond has left active service, blah, blah, blah. So, I mean, yeah, of course, you can test it out further with your information. I can go to details. I can check which sources were used, which top entities were used, what are the chunks being used, how you're finding this information. So that's the explainability part that I was referring to. I can go back and see where and how and what the score was. I am getting a similarity score, but I'm also getting some connections in between. Now, I can explore this further in my console as well. If I go to my console, that's how my graph will look like. Oops, wait. So I have two documents. So I have one for Transport for London, one for James Bond. I can just open it up and I can see all my chunks which are connected with James Bond. Yeah, and each of the chunks will have some text, will have the embeddings as well. Everything is there for you, easy to test it out as well. All right, so that's the one that I would love for you to test out, check, try it, any feedback, any recommendations, anything else that you want as the features. Always, you can just directly go to the GitHub issues over here, just open it up, or documentation, read more about it in the documentation as well. But yeah, this is one example I wanted to test out. I actually tried it out with a bunch of other questions. First movie, last movie, plot, actors acted in other James Bond movies as well, did this actor. I mean, I also asked, I asked the first one, first movie adaptation, it was Dr. No by Sean Connery, and then did this actor acted in other James Bond movie as well? And then it smartly asked me, are you referring to Sean Connery? I said, yes, I'm referring to Sean Connery. And then Sean Connery was the actor to portray in a bunch of other movies. And yeah, that's how you can play around with this tool to get to know more about what GraphRAG is. So this is where it's hosted, llm-graphbuilder.neo4j labs.com. It's a labs tool for now. There's an entire documentation that you can check out. If you want to take a snap of it, keep the URL with you. YouTube transcripts, PDFs. There was a nice demo which our CEO ML also did at AI World Engineers Forum somewhere in Paris, I guess, where he did a combination of YouTube videos, transcripts, PDF, Wikipedia pages, everything into one single. I mean, it's optional if you want to use a single database for everything, or you want to have multiple databases. That's also an option for you. If you have, let's say, for a same use case, you have a bunch of different different sources. One is in YouTube, one is in the PDF, other one is a web source. Then probably you can create a nice graph within the single database itself. And as I said, it's an open source project, so you can always run it as a Docker image in your local desktop. You can test it out with the local LLMs as well. If you want, if you're not liking GPT-4o or Gemini or Diffbot, you want to switch to Llama or Claude or anything else, just connect with the local LLM also and test it out. Yeah, go ahead and try it out. I would love to hear how it works. And almost towards the end, just wrapping it up quickly with the governance part. As I said, you can govern your retrieval or your information that's coming in from your LLMs by putting in some access control policies down to your node level as well. And that's super, super critical for enterprises these days, that how I can isolate some information, make some information available. So you can quickly and easily do that in knowledge graphs. And of course, the explainability part, which we already saw, that where the data is coming from, which sources, which chunks, which entities are being used. So everything is available for you. And all along, this is how your entire GenAI reference architecture will look like. If you look from left to right, you'll see there's a data ingestion process. You have data sources, which is structured, semi-structured, unstructured, whatever it is. You pass it on to LLM Graph Builder tool, or you build your own code samples, code projects. It generates a knowledge graph for you, ultimately, which you can visualize it in Bloom. Everything sits into Graph Database. You can run Graph Data Science on top of it. And then what you see from right to left is essentially your end user cases, use cases, end user use cases. Again, not just limited to them. And then you can interact via chat or any other mechanism that you want to. So these are some use cases: ticket triaging, recommendations, news discovery, easily doable in GenAI. All right, so leaving you with some of the resources, if you want to test out a nice workshop, in the between I mentioned about a workshop that we did day before yesterday at Graph Summit Europe. So if you want to also play around with this, you want to see the content, what we talked about, you can just go to this URL and play around with this. It's a nice workshop to know the personalizations and recommendations as well. And some more resources. This is our GenAI hub, neo4j.com/labs/GenAI-ecosystem. That's where all the integrations that we build in the GenAI world, everything sits under one single place. If you recall, I mentioned that there's a free offering from Neo4j, so you can either go with the sandbox, which is a limited duration, but you can also go with Aura Free, which is our lifetime free offering, but a limited instance with 200,000 nodes and 400,000 relationships. Good for prototyping, pretty amazing. But the professional is also not too expensive. You can always switch from free to pro. Or if you want to go from pro to enterprise, there's a new tier that we launched. It's called Business Critical, which is much more competitive in pricing and better offerings as well. So continue your graph journey with Graph Academy. It's a one-stop solution for all the graph and GenAI content. It's not just restricted to graph. Most of our GenAI things that we are working on, we put in a nice course format as well and made it available to you in one place. We are launching a course almost every 2 weeks, every 3 weeks. Yeah, almost every month for sure. There are nice two nice certifications as well, Certified Professional. Both of them are free. There is a Graph Data Science certification also, so test it out. And this is another course, deeplearning.ai course that we launched earlier this year with Andrew. So if you want to learn more on whatever we discussed today, also and then a little expanded version of it. Not too big, 2.5 hours long course. You can also check that out. And this is the last one, trust me. This is the Nodes online conference that we run every year. This is the 6th edition of running this. We run this across all the time zones, APAC to EMEA to Americas. We are running 4 tracks this year. I've never done this 4 tracks before. There's such amazing speakers, 145 plus technical talks from Neo4j and also from community. It's not our own conference alone. We don't have just Neo4j speakers. We have speakers from outside as well. Amazing conference, trust me. If you really want to learn about different use cases, what people are like, developers are really working on Neo4j, this is one place to go to. We will have an amazing keynote from Ben Lorica as well. So just go ahead and register yourself. And this brings me to the end of my talk. Thank you so much. And if you have any questions, do we have time?
Thank you, Siddhant, for such a wonderful session. We do not have enough time, but we can take up one question right now.
OK. You pick.
Yeah, thank you so much for the talk. It was really, really interesting. So I would really love to understand how did the lithium shortage case work. If you could like walk us, hey, I submitted this query, here is what the next step, and then it will find this information in the graph, and it will go here and here, and that would be amazing. Thank you so much.
I think we can take this offline. I can show you how it's working at the back end.
That would be great. Thank you so much.
All right. Cool.
Thank you so much, everyone. You can connect with
much.
Siddhant during the networking break at Spacebar at the end. And we do have a quick coffee break right now, but please join us at 11 a.m. for more such insightful sessions.